Hello, everybody. So today we are going to be covering section 8.2, which will primarily focus on inverse functions. So before we learn what an inverse function is, we have to go through a couple of definitions. So the first definition I'm going to cover is a one-to-one function. A one-to-one function is when no two ordered pairs in F have different x coordinates and the same y coordinate. And when I say F, I just mean your function. So it can be F, G, H, Z, whatever. It doesn't matter. All right? And then I have these examples here, but before we do these examples, we have to know what is a function. A function is when no two ordered pairs in F or whichever F, G, H, doesn't matter, have different y coordinates and the same x coordinate. All right? So first we have to check. So when we do these examples, the first thing we have to check is we have to check to see if it's a function. So what I do, I hope you recall, is that we're going to look at all of the x's, right? And we're going to see if any two are the same. I have 1, 2, and -2. Since all of my x's are different, that means this is a function. Now that we know it's a function, we can now check to see if this is one-to-one. So similar process to check to see if it's a function. The only difference is that we're going to be looking at the y coordinates. All right? So what I want to do here is, as if we were seeing if something was a function, we're going to see if any y's repeat itself. And so I have 4, 3, 4, so they do repeat themselves. 1, 4 repeats, and then this -2, 4. So, but it says that we have no two ordered pairs can have different x coordinates and the same y coordinates. So they have the same y coordinates, but I have x equals 1 and x equals -2. They're different. So what does this tell us? This tells us that this is not 1, 2, 1. So that's how we kind of denote one-to-one, just 1-1. So this is not one-to-one. All right? So the next example, okay, we have to do the same thing. So we have to check to see, is this even a function? So look at this. Right? So I have 4, 3, 4. Okay, since these x's, so this 4 repeats and this 4 repeats. So now what I have to do is I have to see, are the corresponding y's, are they the same or are they different? In this case, these are different. So what does this mean? This isn't even a function, not a function. Okay, since it's not a function, this just means so it's also not one-to-one. Okay, because it's not a function. Right. Now our last example is h is equal to 3, 2, 2, 6, -1, 4. So again, we're going to check, is this a function? Okay, so I'm looking at 3, 2, and -1. So in this case, all the x's are different, so we know that this is a function. Now, let's check our y's. So I have 2, 6, and 4. 2, 6, and 4, they're all different. So what does this tell us? This tells us that example 3 is a one-to-one function. All right? So now that we know what one-to-one functions are, now we can learn what an inverse function is. An inverse function is if f is 1-to-1, or if your function is 1-to-1, and it's represented by ordered pairs of the form x, y, then the inverse function, which is denoted by f to the -1, is the set of ordered pairs y, x. So what does that mean? So the domain. So look at this note over here. It says that the domain of f is the same as the range of f inverse, and the range of f is the domain of f inverse. And that makes sense because if we look, so for f, if I have f and then this is xy, Let me change my color here. Okay, so let's say this is f and then this is xy. Okay, and the f inverse we know is yx. Okay, so if we look at this, what is this domain? Domain is the x value, so it's just x, and then the range is the y values, and in this case it's just y. But if we look at this f inverse, what is its domain? Its domain is y, and the range is x. So as you can see, so the domain of f is the same as the range of x. So if we look at this, oops, let me just, so if we look at D, so the domain of f is x, and the range of our f inverse is x, right? So this holds true. And then the range of f is the domain of f inverse. So what is that? So the range of f, so we know that is y, and then the domain of f inverse, as you can see right here, it is also y, right? So this will be really handy when we try to look for domains and ranges, because sometimes one of them is easier to find than the other, right? And you'll see as we go on, right? So I have a little typo here. It says, so for example 2, okay, this is actually example 3. So what is the inverse? So since this is 1-to-1, that means that h has an inverse. So what is the h inverse? So these are my xy's. Okay, so this is yx, right? So as you can see, so xy, so this is 2, 3, and then it's 6, 2, and then 4, -1. It just switches spots on all of them, right? So now we're going to talk about the property. So it's called the inverse function property, and it states if f is a 1-to-1 function, then g is the inverse of f if and only if f of g of x equals x for all x in the domain of g, and g of f of x equals x for all the x in the domain of f. All right. So what does that mean? So this if and only if means, so if g is an inverse of f, then these two properties hold. If and then the other part means that if we get f of g of x and g of f of x and they both equal x, that means we know that g and f are inverses of each other. All right. So one question you may have is, so what if, so if we have f of g of x, and then what if it equals, like, let's say g of f of x, and let's say they equaled, I don't know, x minus 2. This does not mean it's an inverse function. They are not inverses of each other. They have to equal x. So even if they equal each other, if they both equaled x squared, if they both equaled, I don't know, x plus 3, 2x minus 4, I don't know, whatever combination that is not x, they are not inverses. They have to equal x, right? So these are our notes. So the rest right now are just steps of to determine if they're inverses and to find an equation of an inverse function. And we'll do those in the next videos.